All right, seventh grade, here we go. Today we're going to be focusing on adding and subtracting with scientific notation. So these first couple examples are going to be pretty basic because kind of like when you add fractions, how you have to have a common denominator. When you add and subtract scientific notation, you have to make sure that your exponent is the same. So essentially, when I look at this problem, what it essentially becomes is 4.6 plus 8.72. And I'm going to put that in parentheses. And all of that's going to be multiplied by 10 to the power of 3. So now you're going to have to go in. You're going to have to go to your calculator, or, well, I'm not even going to go with the calculator. I'm just going to come over here, 8.72, and I'm going to add 4.6. Of course, you want to keep your decimals lined up. 2 and nothing is 2. 7 plus 6 is 13. Put the 3 down, carry the 1, drop the decimal. 1 plus 8 is 9, plus 4 is 13. I get 13 and 32 hundredths. So this becomes 13 and 32 hundredths times 10 to the power of 3. The problem is your answer has to be written in scientific notation, okay? And since this number is bigger than 10, this cannot be the final answer. So I'm going to have to adjust the decimal so I have a number that is at least 1, but less than 10. So I'm going to move my decimal over to here, and I'm going to make this 1 and 332 thousandths. Now, it told me originally that I was going to move the decimal 3 places to the right because it's a positive 3 as an exponent. And I was going to be moving it from here 3 places to the right. But I've backed it up once. I moved it back 1 place to the left. So now, to get the same answer, I would have to move it 4 places to the right. And I would end up as 1.332 1 and 332 thousandths times 10 to the power of 4. Subtraction works the same way. 9.2 times 10 to the power of 8 minus 4 times 10 to the power of 8. I'm just going to do 9.2 minus 4. Of course, we know that that 4 is like 4.0. So drop my decimal straight down. 2 minus 0 is 2. 9 minus 4 is 5. 5.2. All right. So I end up with 5.2 times 10 to the power of 8. Well, personally, I like that just the way it is because my factor here is just fine. It is at least 1 and less than 10. And so that's working just fine, times 10 to the power of 8. All right, well, let's change gears a little bit. It's still just adding and subtracting, writing your answer in scientific notation. The difference is now that my exponents are not the same. And to make them the same, okay, I have to so I have to make them the same, which means either I have to choose, either I want my 6 to become a 5, or I want my 5 to become a 6. Well, in this situation, I guess it really doesn't matter, but you can choose which way you want to do it. There's always one way that's easier than another. And if you start to think about it, and I'm going to go over this one kind of both ways so you can kind of see. Let's say I want to take this 6 and I want to make this 10 to the power of 5. All right? Well, that means that from here, I would have been moving it 6 places. But now I'm only going to move it 5 places to the right, which means I'm going to need to move it over once and make that a 97. So that's going to become 97 times 10 to the power of 5 plus 6.7 times 10 to the power of 5. Now I just do what I did before. I take 97 and I'm going to add 6.7, of course, keeping my decimals lined up, remembering that can be a 97.0. 0 plus 7 is 7. Drop my decimal down. 7 plus 6 is 13. Put the 3 down, carry the 1. 1 plus 9 is 10. I get 103.7. So that's interesting. I get 103.7 times 10 to to the power of 5. Now, clearly, that is not in scientific notation because that is not at least 1 or less than 10. So even if I move it once back, I'm still at 10.37. That's bigger than 10. I'm going to have to move it twice, 1.037. So this is going to become 1.037 times what? Well, it told me that if my decimal was here, which is where it was originally, I was going to have to move it 5 times to the right. But to get it in scientific notation, I backed it up twice, which means now to get to the same place, it's going to be 7 times that I need to move it. 1.037 times 10 to the power of 7. Now, I want to point something out. Now, if just real quick, I want to point out, now let's say, for example, I would have taken this 5 and made it a 6 and done that. Well, that means then that instead of having the decimal here and moving it 5 times, now it wanted me to move it 6, so I would have had to back it up once. All right? And I would have ended up with 9.7 plus 0.67. All right? Because that's what this originally was, 9.7. So when I do that, that's 7. 7 plus 6 is 13. Drop the 3, carry the 1. 1 plus 9 is 10. 10.37. So it would have been 10.37 times 10 to the power of 6, but I would have had to back it up once and make it 1.037. And now instead of having to move it 6 times, since I backed it up once, it would have now had to go 7 because it one more extra time, times 10 to the power of 7. So I get the same answer either way. So it just depends. But usually one way ends up being better than another. All right, so I've got 3.5 times 10 to the power of negative 2. I've got minus 6.6 times 10 to the power of negative 3. So this is what I'm going to do. I know I have to think, 7th grade, when I subtract, I want to get an answer that's going to be less than 1, not less than 1, less than 10, sorry, but it has to be at least 1. So I'm thinking what I want to do is I'm going to take this negative 3 and I'm going to make it a negative 2. And I'm going to show you why I'm thinking that way, trying to help your brain think this way. Because at negative 3, it's telling me that this decimal would have to move 3 times. But if I only have to move it twice, that means that I have to change this number to 0.66. That way then now to get the same answer as I would 3 places from here, 1, 2, 3, I would only move it twice here, 1, 2, and be at the exact same spot. So really what I'm doing is now I'm doing 3.5 minus 0.66. Well, I know that I don't just drop the 6. I put a 0 there because my decimal lines up. Borrow from the 5, make it a 4, make the 0 a 10. 10 minus 6 is 4. I can't do 4 minus 6, so I borrow from the 3, make it a 2. 4 becomes a 14. 14 minus 6 is 8. Drop the decimal, 2.84. I like 2.84 because it is at least 1, but it's less than 10. So my final answer ends up being 2.84 times 10 to the power of negative 2. All right? You folks have a good day. We'll talk to you later.